Hello everyone. It's tutorial number 5. Tutorial number 5 شباب, it's mainly on positional logic, logical equivalence, and inference rules. Okay. So as indicated here in question number 1, you may use this website in order to check the tautology, the contingency, and the contradiction of any compound proposition. But in exam, you're not be able to use it. So please use it as a checking tool for whatever you're gonna do it using your pen and notebook. Okay. So let's do the first one. The first one is P or not P. How can we do it? It's very easy. If you'd like to do it in truth table, so this is P. Here I have only one variable, so it has two values, true and false. And not P is the negation of true is false, and the negation of true is false is true. So here you're going to do P or not P. So here the or between true or false is true, and here the or between false and true is true. So which means that this is tautology, okay? But if you'd like to check it, so it's very easy. Let's access the website. So here is the website, web. Here is the calculator. You can write down the expression you want and press enter. It will be calculated, and one of those slits will be lighted to indicate whether it's tautology, contingency, contradiction, or any other thing. Okay. So let's try to write the first expression. The first expression is P or negation Where is the negation here? Not P. And enter. So it runs the calculation. And here, as you see, the LED, which is keep flashing, is the tautology LED. Okay, so the first one is tautology. And clear, and do the other one Q and not Q. Q and not Q. So this should be a contradiction, يا شباب. Enter. So this is a contradiction. The first one indicates a contradiction. Okay. So the last one, يا شباب, is packet P double implication, which is if and only, sorry, this is single implication, implies Q, close the bracket, double implies if and only if R. So when you calculate it, it's contingency, okay? Is it clear for you? And we have done such of those calculation before in the previous tutorial, and you can build the truth table for it and check whether all the values are true. So it's a tautology. If all the values are false, so it's a contradiction. If there is a mix between true and false, so it's contingency. Okay, Shabab? Great. So question number 2. Question number 2 is to use propositional logic calculator to check whether this is equivalent to that one. So how can we do it? In order to do it, يا شباب, so would like to represent this side and check whether it's equivalent to this side or not. But this operator, I don't have an operator like equivalent in the calculator. So how can we do it? It's very easy. So try to read it again. It means that this happens if and only if this happens. If and only if, يا شباب, it means if the left side is true, the right side is true. If the left side is false, the right side is false. Okay, شباب? So this is if and only if. So if and only if is exactly the same as equivalent, يا شباب, which means that you can represent this as this equation, as this compound proposition, and I check whether this compound proposition is always true, which is a tautology. If it's a tautology, so it means that the two sides are equivalent, okay? Okay, so how can we do it? Using truth table, you can do it easily, but let's check using the calculator. I'm gonna do P implies not Q, not Q, double implication, which is if and only if, not P or not Q. And let's try to calculate it. And it shows that it is a tautology, as you see, which means that the first proposition is equivalent to the second proposition. Okay? Okay, great. So that the following argument is valid. Okay. What's the following argument? And we're gonna do it using two different ways. The first one is to apply the rules of inference, and the second one is to check it using the propositional logic calculator. Okay. If today is Tuesday, then this is Belgian. So today is Tuesday, let's say this is P. Then this is Belgium. So I'm gonna say this is Q. And you know that today is Tuesday, so which means that P is true. Then you want to prove that this is Belgian, which is Q. So how can you do it? It's very easy using rules of inference. I'm gonna say, let's model the first compound proposition here. The first one, this is line number 1, is P implies Q. And the second one, the second premise is that today is Tuesday, which is P. And you'd like to prove that it is Q. So it's very easy. You can do it in many different ways. You can say 1 and 2 by applying modus ponens. So if the left side is true of the implication, then the right side is also true. Okay? And it's done. But also you can do it in another way, which is much more professional. So يا شباب هنا, what would you like to prove? You would like to prove that Q is true. We're gonna have a lecture dedicated for proving methodologies. And one of the proving methodology is proof by contradiction. What's a proof by contradiction يا شباب? It means that دلوقتي you would like to prove that Q is true. Guess what? If you assume the opposite, that it is not Q. So you assume the opposite of what you want to prove. And you use it as a premise now and go in your proof and prove that your assumption is wrong. If the assumption is wrong, it means that the original statement is true. This is proof by contradiction. Okay, شباب? طيب, let's do it. أنا دلوقتي I assume the negation of what I want to prove. What I want to prove is Q, so assume that no, it's not Q. And using modus tollens between 1 and 3. If it's not Q, then it's not P, okay? So it's not P. So now, using line 2 and line 4 together, can you have a proposition and its negation both are true at the same time? No, it cannot be. ماشي يا شباب? So the proposition, its true value, its positive value, or its negative value should be true, not both of them, which means that this is false. And here I use this symbol to indicate false. It cannot be, this is a contradiction. If the negation of what you want to prove is a contradiction, which means that what you want to prove is a tautology يا شباب. وده الصح، اوكي؟ So دلوقتي شفنا ازاي نثبتها and you can do it also باستخدام truth table. How can I do it باستخدام truth table? It's very easy. You want to prove that this is P, this is Q. If it's P, then Q. So actually, this compound proposition is that if it's P, then Q. And you know that it's P. And you'd like to prove that it is Q. So this is the equivalent compound proposition for the scenario shown in example 3. Let's try to implement this scenario on the calculator and check whether it's a tautology or not. And it should be a tautology in order to be valid يا شباب, okay? Type, okay. So I'm gonna say clear here, P implies Q and it's P, then it is Q. And calculate, and as you see, it's being shown as a tautology يا شباب, okay? So if you would like to check it using your own work, you can go and write down a truth table for it, P, Q. So here, true, false, true, false, true, true, false, false. P implies Q, it's P implies Q. Let's do it. True implies true, yes, true. True implies false, no. False implies true, it's true. False implies false, it's true. Ended with P. Ended with P, okay. So P implies Q, ended with P. So here, true and true is true, true and false is false, false and true is false, false and true is false. So I'm gonna have the overall expression here. This is the left side, and this is the right side. True implies true, it's true. False implies anything, it is true. So it's a tautology, as you see here, يا شباب, which is being shown by the calculator, okay? Okay, great. So let's go to question number 4. Question number 4 is that you have a scenario and you'd like to model it first, and after that, apply the inference rules to conclude something, okay? Sometimes an argument is just a set of premises followed by a conclusion. In many cases, however, an argument also includes intermediate steps that show how premise led incrementally to the conclusion, show that the following argument is correct. Okay, how can we do it? First of all, you'd like to model it in a correct way. So here is the first if then. If today is Tuesday, then I have a test in mathematics or economics. So I'm gonna use T to model this proposition. Today is Tuesday. I have a test in mathematics. I'm gonna use N to denote it. I have a test in economics. I'm gonna use E to denote it. And actually, this statement, it means that if it's T, then it is M, and is it and or, sorry, or E, okay? And if my supervisor, if my economics professor is sick, I'm gonna use that my economic professor is sick, denoted by S, then I will not have a test of in economics. So then not E. And as you know, today is Tuesday, so now you know that it's T. And my economic professor is sick. My economic professor is sick. This is S. Therefore, you would like to conclude that I have a test in mathematics. You'd like to conclude that it's M. Okay, it's very easy, Shabab. Okay. How can we proceed? Using the rules of implication. It's very easy. This is 1, 2, 3. As you know, this you can apply simplification rule. So simplification rule in rule 3. T and S, it means that it's T and it's S. Okay, Shabab? So as you know that if it's S, using 5 and 2 and applying modus ponens, so you can conclude that it's not E. Okay, and using 4 and 1, using modus ponens also, here you know that it's T and T is the left side, so you conclude the right side. So the right side here is M or E. So you know that M or E is true, but you already know that E cannot be true. So it means that M should be true, which is what you want to prove. Okay, Shabab? Okay. So let's do it in the other way. Let's شرحها من شوية. Let's do it by proof by contradiction. I know ان البروف by contradiction انتوا لسه مش خدتوه بس خلاص نتدرب عليها سهلة قوي. أنا دلوقتي I'm gonna say that okay, I'd like to prove that M is valid. So I'm gonna assume the opposite. The opposite is not M. This is the assumption, okay? And I will try to conclude that this cannot be true. Okay, so very good. Using simplification rule. Simplification rule, ya shabab, is what? Is 3, it could be simplified to have T and S at the same time. And if you have S using modus ponens, so you get not E. And if you have T using modus ponens and rule 1, you get M or E. But you know that M or E is true, but also you know that E cannot be true, so it's M. So ya shabab, دلوقتي, here I have, you concluded or you assumed that not M is true, but however, you concluded or you indicated that M is also true. So this is a contradiction in Shabab, okay? Which means that this cannot be true, it's false. Okay, so if the opposite of what you want to prove is false, so what you want to prove is valid, it's true, okay? This is proof by contradiction. Okay, great. Question number 5. In each of the following cases, you are given a set of assumptions and conclusion. Your task is to use the inference rules to prove the conclusion from the assumptions. So here يا شباب, it's not P, and this is step 1, and not P implies Q, this is step 2, and you would like to prove that it's Q. Okay, this is very easy. Not P, actually, this is the left side of the implication shown in step 2. So by applying modus ponens, you conclude that it's Q. Okay, Shabab? Okay. How can you do it in the other way using proof by contradiction? It's very easy. In order to do it, let's prove, or let's assume the negation of what you want to prove. I'm gonna assume that you'd like to prove that it's Q. Okay, I'm gonna assume that it is not Q. Using modus ponens between 1 and 2, you're gonna conclude that it's Q. So 3 and 4 contradict each other, which means that the negation of what you want to prove is not valid. So what you want to prove, it is valid. Okay, Shabab? Okay. So again, Hannah, it's not P, and not P implies not Q. So again, this is the left side. Using modus ponens for equation 1 and 2, you're gonna conclude that it's not Q, and this is what you want to prove. Here, it's a little bit complicated, okay? So P implies Q is a premise, and the second premise is not P implies R, and the third one, it's not Q, and you would like to prove that, then it is R. Okay, this is okay. So not Q is the right side of this implication. So using modus tolerance between 1 and 3. So if you have the negation of the right side, so you can conclude the negation of the left side also, not P. So this is step 4. And not P, as you see here, ya shabab, this is the left side of this implication. So you can apply modus ponens between 2 and 4 to conclude that it's R, and actually this is what you want to prove, okay? Okay, this is great. Use propositional logic calculator to show that the arguments in question number 5 are true. So it's very easy. It's a matter of converting the argument into an equation, and you check it on the calculator, or you construct a truth table for it and check whether it's a tautology or not. So here, how can you represent it? It's very easy. You can say not P and, so the conditions ANDed together, or the premises ANDed together, not P implies Q, and here implies Q, implies the conclusion. Okay, Shabab? Okay, so let's try to do it. Bracket, sorry, I'd like to clear it first. Bracket, not P, and another bracket, not P implies Q, close the bracket, implies Q, and calculate. It's a tautology, so it's valid. Very good. How can you do the second one? It's very easy to do the second one. So you will link all the premises together by and, not P, and not P implies not Q, then it's not Q. and link the premises with the conclusion by implication, okay, as you see. So let's clear it, bracket, not P, and bracket, not P implies not Q, close the bracket, implies not Q, and enter. It is a tautology, which is valid, okay? So a third one is to link all the premises by and, which means that you're gonna write down P and Q. Sorry, P implies Q and not P implies R and R. Is it R? No, it's not Q, sorry. And not Q implies R. So to do it, let's clear the calculator and write down the expression. P implies Q and bracket, not P implies R and not Q. So this implies R and enter. It is a tautology which is valid, ya shabab. And this is the end of tutorial number 6, okay? Thank you very much and have a good luck.